before I worry about the average value, first thing I want to do is just figure out what is the total area under that curve. So from -3 to 3 of 9 minus x squared. Let's see, 9x gives me a derivative of 9. Minus 1/3 x cubed gives me a derivative of -x squared. I haven't evaluated the -3 and the 3, so I have to put those or it's not correct. One time I'll plug in 3, which would be 27 minus, let's see, 27 divided by 3 would be 9. The next time I'll plug in -3, which would be -27 minus -27 divided by 3 would be -9. So minus a negative becomes a plus. So I get a 27 minus a 9 plus a 27 minus a 9. So these two would be 54 minus 18. Same thing as 56 minus 20, so 36. Okay, so I did all that work, and you can see out of habit I started to circle my answer. But I got to be careful. This question's different. It's in a different section. It never asked me for what is the area under the curve. It wants me to find the average value. Well, if this is the total amount of area, I should just be able to divide this by some number to get the average value. So what do you think we should divide this by? 6, because the difference between bounds is 6, so it's like we're dividing it into 6 equal pieces. So the average value is actually 6 square units. So that's the first answer they're looking for. Okay, second part of the question is, what value of x makes that happen? Andrew, you need to put your phone up, please. So we can take the function. When does the function have a value of 6? And that gives us something to solve. Take the square root of both sides, and I get the square root of 3. If you went to the square root of 3, drew it to the function, that y value times this x value, 6, that rectangle has the same area as the total area under the curve, 36, which may have a bunch of curvature to it. But I skimmed over right here. Easy arithmetic mistake to make. I took the square root of both sides. You have to do plus or minus. And both of these are between -3 and 3. So positive square root of 3 and negative square root of 3 is what's happening there. So algebraically, it's not a hard thing to find, but I really do think that looking at that visual on the PowerPoint, which is why I do that, seeing that rectangle and that it has the same area as the area under the curve, that's what you're trying to find. What x values make that occur that way?